T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engines full power. And liftoff. Go Falcon, go IMAP, go SWFO-L1, and go Carruthers.
And we are flying 3 new missions on a million-mile journey to track space weather. Good looking flight so far. Our tracking cameras getting a great shot as this mission climbs into the sky. We'll be looking now for those engines to throttle down as we go through max Q, the time of maximum dynamic pressure on the vehicle.
Falcon 9 power and telemetry are nominal.
That's right, so coming up is max Q, which is the maximum aerodynamic pressure, largest structural load the vehicle will experience. So slowing it down helps to reduce some of the load it experiences.
Falcon 9 is supersonic.
And that will help us recover and reuse the first stage. Following max Q, we'll be able to throttle those engines back up as atmospheric density drops.
Max Q.
And back chill.
T plus 2 minutes into flight, you can see all 9 Merlin engines. You can at least see the exhaust from 5 of them there. Beautiful shot looking back to the Earth. Got a couple quick call outs coming up. We're going to shut off the engine at 2 minutes and 29 seconds. Stage SEP at 2:32, and then our first burn begins at 2:40. Here we go.
Stage separation confirmed.
And there it goes. On the left side of your screen, you can see the first stage booster falling away now. And on the right side, our second stage flying IMAP, SWFO-L1, and Carruthers.
So you can see it there in the image right there. IMAP is spinning up.
There we go. That's that 4 revolutions per minute we were talking about. That is not something that is wrong. That is intentional. You're looking forward. Any moment now, we could have separation of the IMAP spacecraft.
That is a pretty cool image right there.
IMAP deploy confirmed.
There we go.
IMAP
has
deployed.
separated, beginning its mission to map to the solar frontier and reveal how the sun shapes our space environment.
Go IMAP.
You spin me right round, baby, right round. Like a record, baby, right round.
Yeah, there you go.
That's a great view.
It is. It's a great view. But the primary reason we do need to spin stabilized, though, too, besides the angular momentum reasons, right, is it gives us, when we're spinning, we get that full...
SWFO-L1 and Carruthers will follow. Now, for the Carruthers payload, this is equipped with a geocoronal imager, and this will be able to detect fundamental characteristics of the outermost layer of Earth's atmosphere. We're listening in for the deployment of SWFO-L1.
SWFO-L1 deploy confirmed.
Beautiful separation and successful deployment of the SWFO-L1 payload. We're not done yet. We do have one more payload coming up. That's NASA's Carruthers Geocorona Observatory. We already received that acquisition of signal from the IMAP payload.
So
Now,
Carruthers
AOS, as a reminder, this is a
and SWFO-L1 is significant. We are at an altitude of roughly 5,000 kilometers.
Correct. And if you recall, we were looking at the altimeter there on the bottom right screen. We deploy SWFO-L1 at about 3,800 kilometers. And so as we're on that escape trajectory I was mentioning earlier, we are seeing our altitude steadily increase as we move to the Carruthers spacecraft also being deployed.
Carruthers, separation confirmed.
Awesome. There we go.
That is cool. Carruthers separating, beginning its mission to capture the faint ultraviolet glow of Earth's outer atmosphere. All three released.
Yeah, congratulations to all three teams.